We're going to discuss the implementation in JavaScript of a very simple state machine. It's a two-state state machine. It's shown over here in purple, and it's a component. And as a component, it has the usual three things. Its name, toggle, has input ports and output ports. If I click here, this is org mode in Emacs, just in case you wondered. So I've used the JavaScript convention underscore for input pins, output pins, and states and stuff like that. So it's got one input pin and it's got two output pins, no and yes. It has two states, off and on. The numbering really doesn't matter. I was going to use strings, but that made the code even harder to understand. So now if we hand compile this diagram into JavaScript, we get one function with a bunch of, one class basically. And that class encompasses a variable called state, and it's set to the initial state. Here we've got the initial state drawn as a circle. Here I've got an initial state that goes to off and another state on. Both of them have a little bit of entry code, which both call a foreign function fire on with that takes a name of a output pin, some sort of value, and so this one fires the no pin, this pin. This one fires the yes pin, and true. Like, I really don't care what's going on, what's going out in those things. It could be a 1 or a 0 or a true or a false. Just the fact that the event was fired is the only thing that matters. Between these two states we have two transitions, one going this way and another going from on to off, and both of them trigger on the input pin in this pin. So if we're in this state and we see something fire on in, then we go to that state, the on state. And if we're in the on state and we see the input pin in fire, then we go to the off state. Now that should be fairly straightforward JavaScript, and it is. And so here's the schematic version of the JavaScript. So we've got the function toggle. It has a state variable, and it starts off at the default state underscore off, and then it's got a step function that says execute the code or the state transitions for one incoming event. When you're done, stop. That's what this does. So we see that the step function breaks down into basically a case statement, a switch statement, and it switches on the state of the machine. If it's off, it does some code, and if it's on, it does some other code, and by default, in this case, it's going to fail. We have an enter function that does something given the next state. So in this case, if we're here and we're going to this state, then the next state is on. If we're in the on state, the next state will be off. And that will be passed into here, and that function, the enter function, executes these fire operations, and it'll set the state variable of the state machine itself. So far, should be straightforward JavaScript, and I hope it will turn out to be that way. If we look at the switch statement for the step function, in the off state, it says that we break down the off state again into a switch that switches on the event, the tag of the event. So the tag will be this thing in. That will be the tag, and there will be data associated with that tag. And the on state also switches on the same tag. As we'll see, the state machine does that. So when it's in off and it sees an incoming event on in, that's the tag in, then it will do something. It will transition to the on state, and going into the on state, we fire yes to true. fire true to yes. And if we're in the on state and we see an incoming event with tag in, then we go to the off state, and when we enter the off state, we fire true to no. Again, not rocket science. And that just breaks down into more case statements. And here we finally have the code. So if we're in the off state and the tag is in, then we enter the on state and we break. Otherwise, we throw up our hands and say something's terribly wrong. Likewise, so when we're in the on state and we see an input event with a tag of in, we enter the off state, which is what this state machine says to do, and then we break. Otherwise, we throw up our hands. I'll collapse that, and the default basically says throw up our hands. And then we look at the entry function, and it switches on the state to the next state that we want to investigate. And if the next state is off, then we set our own state to off and we break. And we also perform this function, fire true off to no. And that's what if the next state is off, if we're entering this state, then we fire true to no. And if the next state is on, we're gonna set the state variable to on, and we're gonna fire true to the yes pin. The interesting part here to look at is that other than calling the fire function, all this stuff is generated by this diagram, from this diagram. And one can see the correspondence. If one knows how to write languages easily, and I'm going to show you how to do that in using OhmJS, then this can be compiled. This diagram can be compiled to this kind of code. Right now we're compiling it manually by hand. Just to finish off what we're doing here, we've got foreign functions. So there's one foreign function, or deferred function, maybe I should call it that, deferred function, which is the fire function. And in this case, I don't want to do very much. I just log the event to the screen and be done with it. We also have a bit of a kernel. We'll flesh that kernel out later. We'll find that that we want to have input queues, and maybe we want output queues on each of the components, and that will sort of break the call returnness of everything and make things work in a much nicer way. And here we have a function called send. Actually, that's not called anywhere. I'm anticipating. We do call inject, which is sending from the outside world into the state machine and then causing the machine to perform a step. The inside world send is what you would call if you were inside the state machine writing more interesting code than just this fire function. And if we had input queues and output queues and a little kernel that ran the queues and pulled off one event and threw it at each component as it wishes, then the send function would be what you would call inside these states. And at the very top level of everything, we have that we create the class toggle, and then I call inject 3 times. You don't have to do this, I'm just showing it being done. We're injecting it into the top part, which is returned by creating the class toggle, and we're sending in an event which has a tag. It always comes in on the in pin, and in this case we don't care what the value is, so I'm just jamming true in there because I think that's really cheap in JavaScript. Now I've written a bash script that will strip off all these extra stars at the front and turn it into just raw JavaScript. And there's a couple of lines here, like this line, the toggle name, and the input ports. Actually, I should probably put name in here. Name toggle. Input ports, output ports, states, foreign functions, kernel library. All that stuff is just going to go in the garbage. We just need it for reading what's going on here. And that I've put into something called run.bash. Here I am, every time I see input ports, like this line, I just delete the whole line. Output ports I delete it, states I delete, top level I delete, kernel, foreign functions I delete. And then I send it through a sed script that gets rid of the leading stars plus one space and puts it into a thing called temp.js. And then we run node on temp. And in fact, just before starting this, I added the name space something D backslash is shell script format. And then we're going to try to run that shell script. It's ./run.bash, and it calls, and it shows the three outputs corresponding to each of the three calls that I made at the bottom here. These three injects cause the state machine to step, and it stepped from outputting onto output 1, which I think, what did I call it? Output ports. Yes, it's the yes port. It output a don't care, which we happen to use true. Then the next time I called it, it switched back, firing a don't care to the 0th output port, which is no. And so it's in this state. And then we did it one more time, and it switched to the on state, where it output to port 1, the yes port, a don't care.